Hello, I'm not going to talk about Java, is that okay? You probably had a lot of Java, and you've got a lot more Java to go to, and you're probably going to go to your jobs to do more Java. So I'm going to not talk about Java. I'm going to try and broaden the conversation a little bit, to try and figure out... the problem is, how many of you here are programmers? Oh, that's unfortunate. See, I should really go home, because you're not really the audience I need to talk to. I need to talk to everybody else. And to be honest, you need to talk to everybody else as well. I mean, how many of you have super exciting conversations about programming to non-programmers? Think about it, right? But how many other industries are like that? If you're a sports person, if you're a professional sports person, can you only have sports conversations with other professional sports people? Of course not. Like, if you're an artist, can you only talk about your art to other artists? Of course, there are going to be very nuanced conversations which are very specific to what you're talking about, which you can only talk to other professionals or people who are suitably so far in deeply in the thing you're doing that you can only talk to them about it. But you can broadly talk about sports to other people, but we can't yet broadly talk about programming. And I think that's a real problem in our society that we need to try and fix. And I think there's two main ways to try and tackle this. Firstly, we need to find ways to get people interested and motivated to see and understand and explore and engage with programming. And secondly, we've got to figure out how to actually get them started. Right? So they're the two problems I'm trying to solve. And so really, you're not necessarily my audience, but the things I'm about to say in the next few minutes possibly might help you talk to your actual real friends who aren't programmers about programming. That would be cool, wouldn't it? I enjoy doing that now. Because how many of you have gone to parties and someone says, "What's your name?" And you say, "Hi, I'm Sam. What do you do?" "I'm a programmer." "Oh, okay." Like, it happens all the time. Like, why is that? Can we actually not? So now I don't say I'm a programmer anymore. I say, "Hi, I'm a musician." "Oh, cool. What do you play?" "Code." But you've already got the conversation started, right? And they're like, "Oh, how on earth is that going to be a musical instrument?" And then you can get started, right? So I think we need to find ways to do those two things. How do we engage people who aren't programmers in programming, and how do we get them started? And so that's what I'm going to talk about. And the answer is not Java, okay, to those things. It's not any programming language. My answer, which will hopefully come on the screen in a second, which I've been working on for a few years, is a thing called Sonic Pi. Has anyone heard of this thing? Yes? Oh, cool. So some of you have. Now, all of you have. You've all heard of Sonic Pi now. Sonic Pi is a tool for turning text code into music, okay? And it's designed to teach children how to code, so we can get started really, really simple. So I've taught children from 6 upwards, although about 8 or 9 is a really good sweet spot because they're all engaged, they're all interested, they don't know what programming really is. Whether they're boys or girls, it makes no difference, they're super excited. By the time they're 13, 14, they've already made some preconceptions about what it is. And so you want to get as young as possible to get them to understand that code, and this is the most important thing, and actually, you people are the right people to say these things, code is not just for business. It's not just for making money. And it's not just for companies to grow. Is language only good for making legal documents? Do we only speak Dutch or English or French or German just to write contracts? Or do we use our languages to express ourselves in more beautiful, exciting ways? Could we also do the same with programming? Should we only use programming for business? No, no, no. And I think that this is an important thing. If we're trying to engage our friends who aren't necessarily interested in business, or certainly not interested in how code can make businesses grow, I don't think that's a conversation to have. I don't think that's a conversation to go into schools and say to kids, you need to learn to code so you can get a job in business. I mean, you don't go to schools and say, kids, you need to learn to play sports to get a job as a professional sports person. That's not what you say, is it? You say, you need to learn to do sports because it's good for well-being. It's good for your body, it's good for your mind, it's good to exercise, it's good to do teamwork and to socialize. All these are fabulous side effects of sports, but being a professional sports person is only for the tiny, tiny, tiny percentage of people. And I think it's the same for programming. So how do we have that conversation? How do we make it not about business? And also, how do we make it fun? So in the UK, we've just introduced a computer science curriculum. It's great. So we're teaching kids how to code. And I've seen some amazing resources to get kids started. One of them started off by saying, have fun, which is a good start, with sorting. How many of you have had fun sorting things? You're programmers, so you should all be having fun choosing quick sort or bubble sort or, merge sort. The other one was, and this feels like already on the wrong track. Give binary a try. Give it a try, because once you've tried it, you're never going to give binary a try, as if that's going to get a 10-year-old child salivating to do programming. I've never tried binary. I've always been waiting to try binary. But you don't, do you? So I think we need to find better ways. So what I'm doing is I'm saying, if you can learn to code, you can express yourself in new ways. I think that's really where we should be starting. And then we should be saying, well, how would you like to express yourself? And how can code help you express yourself? Not how can code help you make more money. Well, we'll get on to that later, because I've got a bit of a problem with money. But the other part is, how can you express yourself? I think it's a much more interesting social problem, and it's a much more interesting social challenge. And it's, I think, the way to get more people involved in the conversation, so that when we all go to parties, people can be excited that you're programmers. Okay, that's the mission we've got. So here we are, Sonic Pi. It's an open source programming environment. It's free to download. This is the website, sonic-pi.net. If you've got a Windows computer or a Mac computer or a Raspberry Pi, so you don't need to have an expensive computer. You can get a very affordable computer or a Linux machine, and you can download, you can watch, you can read articles and watch videos. It's good for classrooms. We have a community, so there's lots of people using this thing, teaching and working with it. People are performing with it. So I'm going to show you all these things. There's talks and it goes on books and yeah. Right. But it looks like this. In fact, actually, if you're in a school, it looks more like this. And because the key challenge I found in schools, and have you been to schools recently? How many of you have been to a school recently? Quite a few. I was surprised when I first started this. I hadn't been to a school since I was in school. And, I mean, you're all being really well behaved, all of you. You're all sitting down. You're all quite quiet. Thank you. Yeah. There's no one spinning on the chairs. Thomas, get down off the table. Fred, will you just stop eating that chewing gum? Like, come on, everybody. This is what teachers have to do. I'm going to say something, people, and they'll count down. 3, 2, 1. And then the audience may be a bit quiet, or the classroom's a bit quiet. And then the teacher has the opportunity to say 1 or 2 sentences. What are your 1 or 2 sentences to teach programming? What are your 1 or 2 sentences to get people started and excited by programming? Is it open up Eclipse? Or IntelliJ? No. Emacs? Yeah, no. So I think it's a problem. So this is where this comes in. So you open this thing up and you've just got a text editor. You just type text in. So there's no real problem. There's no projects. There's no starting things, no file systems, no saving things, no configurations, no class path settings, none of that stuff. You just open it up and you get a text editor. And then the next thing is, what is your 1 sentence to get people started? Or you say to children, write the word play. Let's make it a bit bigger for you. Choose a number, press the run button, and you can hear a beep. Can you hear that? Oh, that's lovely. There we are. Beautiful beep. And at this point, you've got your first program. It runs. It's not compiled because it's interpreted, but that doesn't really matter. And you've got a function call, you've got abstraction, you've got numbers, you've got opportunities for learning everywhere. What on earth is 70? Don't know. Well, what is it? It's a number. What do numbers do? They can go up and down. Come on, you're programmers. So, 75. Oh, that's a higher note, and 60, a lower note, right? So you don't need to know about music. You just need to know that notes can go up and down, right? And if you're clever, you're like, okay, what about 60.4? That works in between. Or what about 6 million, trillion, billion, zillion? Well, that's obviously too high for the speakers to produce the sound and for me to hear. But it's also interesting to talk about physics, about what is the range of numbers that we can hear, okay? Similarly, if I go super low, we can start to test the subwoofer. No, maybe 10. Ooh. We're in a cinema, aren't we? That's good. Oh. Right, that's fun, right? So normally when I do that at schools, you can't hear it because the speakers are crappy. But here we are in the cinema. We've got the full bass. So we can explore the range of audio. And then you can start talking about the fact that you can then do 2 of these things, like this. That's a chord. And why on earth does it do that? Well, actually, there's a few things to talk about, and I've only got maybe another 13 minutes, so I'm going to be very quick. But here's interesting, because people have different expectations of what this code does. the simplest explanation is, well, why are we hearing two notes? Well, one is, and this is how it used to work, computers are pretty quick, aren't they? So it'll do line 1, 60, and then it'll do line 2, but so quick after another, you can't tell, right? It's like when you play a chord on a piano, your fingers aren't going to hit all the notes perfectly at the same time, but it's close enough that you can't hear the difference. Although today in Sonic Pi, these are played sample accurately at the same time to 1/44,100th of a second. So it's pretty accurate. So if we want to make a melody, so we can do chords and notes. If we want to make a melody, we have one more command, and that's like sleep. So wait a second before we play the next note. And at this point, you should all be unbelievably amazed. Because, well, it's, okay, you don't even know why you should be amazed. You're just going with it, aren't you? That's good. I like it. Keep going. You should be at this point, we have pretty much all of Western music. That's what we should be amazed about. You can make any melody, any bass line, any Mozart, any Daft Punk, you can reproduce with those two commands. Just like in Logo, right, in the 60s. People were teaching children how to make music, they were actually doing music as well, but predominantly drawing pictures. With pen down, pen up, rotate, and forward, you can draw any picture. With these two commands, you can make any melody, and that's super exciting. So you go into schools and you just teach two commands, and off the kids go, and play, sleep, play, sleep, play, sleep, play, sleep. And I've seen, sorry? Volume. Oh, well, yeah. No, I only can do different notes. So, I mean, yeah, you can, what you can do is, if you ask the guy at the back, he's got, no. Of course you can do volume. So this is where you have parameters to functions, right? So if I say amp 3 and an amp 0.5, you can do that, right? So we can modify things. You can set these things as a global thing, although there's no notion of global. It's all thread local. But you can change these things. You can also change the synthesizer, use synth. There's a bunch of these different things. Right, so you can change the sounds. And what on earth is this chip lead? Let's have a look at this. Here, you can't read it, but these black things are the names of controls. So in the sense of here, I've got this synthesizer with all these different controls on it. These are all physical potentiometers that I have to turn. Here, in the code, I've just got numbers I can put in and parameters. They're just argument names. It's just a hash map, a map of key value pairs. You know, the amplitude is 3. The note is 70, right? So there's a bunch of defaults that you don't need to know about, but when you want to do things like amplitude, or what about like the length of the note? They're all 1 second long. So if I change the release time, so this is synthesizer jargon, to that, and release time of this to be 2, you can change length. So you can go into detail. I've only got like another 7 minutes, so I'm going to go really quickly. But you can really go into detail about this. And this thing here down here, the tutorial will teach you all of these things, so you can go into detail. But the cool thing is, what else can you do? So once you've got all of Western notation in 2 commands, what else will you want to do? Well, what about effects like reverb and distortion? What about loops and conditionals and randomization and functions and abstractions and all these lovely things we do? Of course we can do all those things. I haven't got time to show you them all, but like iteration, this is a standard Ruby code here. I can repeat it 7 times. Lovely. The fun thing, though, is if I use this thing called a live loop. If I try this. Because kids actually, before I do that, I'll show you this one other thing. So you can play the built-in synthesizers. There's also a function called sample, which will let you play any pre-recorded sound. So here's a guitar. I can change the rates. Right, so you can play all these things at the same time, right? But what's really fun, or let's have a look at this. This is good. So there's this sample here, the Amen break, which basically defined like 3 or 4 different genres of dance music. In the early days, NWA used it, and they played at half speed, and they rapped on top. Of course, then you've got like sort of drum and bass style, and then you've got sort of faster jungle. Right, and it's the same sample, just different rates. So you can start to see how easy this is. Right, why are you clapping? That's not fun. You wait. So But what else do you want to do? Like, so a drum sample is just a list of drum hits to play, right? So we can take that, we can ask it for onset 0. We can get the first drum, the second drum, third drum, fourth. Well, why do we count from 0? I don't really understand. Fifth drum, right? And so now I can create this live loop, which is just a loop. Call it foo, sleep for 0.125 seconds, and I can play the same loop round and round and round, which is super exciting. But now, like in the olden days, people like Square Pusher would do random things with this. And so I can, instead of saying play onset 4 or 5, I can pick a random onset. So this is fun. Yeah. Change the sustain and release times. And off we go, right? And then we can use things like randomization. So if I say 8 times, do this. I can use random seed, 3, whatever. Now I've got my rhythm, right? And then I want to be able to have like a kick drum going at the same time. And this is the funny thing. In schools, kids will be doing something like this, right? And everything I'm showing you, and will show you, 10-year-old children can do. Right? That's the important philosophical design. I won't put anything into Sonic Pi unless I can teach it to a 10-year-old child. That makes it really hard. But so kids will do this, and then they'll say, I want a kick drum at the same time. Okay? And the answer to that is, sorry, it's not in the computer science curriculum. You've got to wait till university until you can do threads. All right? Seriously. And you couldn't tell teachers. You can say to the teachers, the kids want to do this. Please, can you teach it to them? And they say, no, we will not teach it. It's not in the curriculum. They have to wait till university. So that's where you cheat, don't you? Right? So live loop is this thing I've created. It's a loop like everyone understands. It repeats and repeats and repeats, but it's also a thread. So what I can do is I can have 2 of these live loops at the same time, bar, and I can do sample, bass drum, house, C for half a beat, and we've got the kick drum going at the same time, right? Make it louder. Right, off we go. So that's pretty fun. So already we're sort of sneaking under... Are we on? Is this working? You good? I think I'm good. I'm just stood on my own cable. I'm too excited. How long have I got left? Oh no, 5 minutes. Okay. Thank you. It's all good. Right. Okay, right. Threads. So we have 2 of these things spinning around at the same time. That's just fun. So already we're sneaking in threads. Teachers don't even know really that that's what we're doing, but kids are happy. The teachers tick off the loop thing in the curriculum. That's all good. But actually, that's not where it stops, because that's not the fun bit. The fun bit is, because this system is not just for doing the things I've talked about, right? It's not just for trying to get kids started. It's not just for trying to expand people's perception of what programming is. It's not just for business. It's also very creative. Because there's no point... If I go to a school and say, look, there's this really cool thing where you code and make music, and say, well, I just got a guitar, or I've got a synthesizer. Why do I need to use this ridiculous text thing? And so you need motivational, sort of aspirational possibilities, in the sense that if you were to spend enough time practicing this, where could you go with it, right? And so here we are, right? Let's have a quick look at this. Here's my Instagram feed. Here is a picture. Oh, I've lost the internet. You can see it. It's very small. There's a picture of, oh, come on. Here is me on stage, on a massive stage it was in Karlsruhe in Germany. And where it's gone away, I lost the internet. I wonder if I can get back to it. Let's see if I can get back to it. And next to it was a massive, same size as this, but outside, display of the code. So as I'm performing, Instagram, I did have it all set up. We're going to get to it. No, it's not. Oh, it is going to work. Here we are. Here we have load more. Toodaloo. Can we make it big? Could we go big Instagram? That's very slow. Lots of other people using the internet. Please don't use the internet. This picture here is of code being projected to the audience, right? So we're not just hiding the fact that we're coding, we're really showing it off. So people go, what on earth is that? So we're trying to get people who wouldn't normally program to see programming in action, right? Live programming, live coding. And I'm not the only live coder, there's many of us. I'm the only one that's really focusing on school children, and I think that's a really interesting problem in of itself. And what else can we do with this thing? Oh, I haven't got much time to talk about the details, but we have like academic papers to talk about the timing systems. So this is how the sleep works. When I say sleep 1, it's not kernel sleep like POSIX sleep at all, because that wouldn't work. So we have very fancy Lamport clock style situation going on, where we've got a description of what's going on, and also Haskell proofs. So if you want to get into that kind of stuff, it's all there. So I'm just trying to show you it's non-trivial, right? Now, what else can we do with this system? So we have a nightclub mode, and I have a bunch of synthesizers, because people want to say, well, actually, Sam, your synthesizers, they're okay, but actually, I've got my own Moog synthesizer, which sounds awesome. Can I use that? So one of the problems was to figure out how can we do this kind of thing. So if I create a live loop called foo, I can actually now send MIDI messages, and let's sustain that for 0.1 seconds. And I have to spell that correctly, otherwise it won't work. And sleep for 0.125 seconds. Now, you can't see it, but my lights are flashing. That's awesome, right? So what's happening here is that we have the Ruby code is sending asynchronous messages ahead of time to an Erlang scheduler, which is scheduling the notes to happen at about 1 millisecond accuracy, which is enough for audible hearing. You can't tell. And then they're arriving at the synthesizer pumping sound out into my sound card, but my Sonic Pi doesn't know about it. So I need one more line of code. It's called live audio. I give it a name, like Moog. I say which input of my sound card I have. So if I have a 16-channel sound card, I can use 16 of these things. I can run that, and then we start to hear the Moog synthesizer. It's huge fun, right? And then, of course, the other thing is I showed you 2 threads running at the same time. Now, if I want to have another thread whilst this is still running, if I had to stop, like when you normally code, right, when you want to modify it, you stop all the programs, don't you? You modify the code, you rerun the test. You stop the code, you rerun the test. You stop. Right? That's not going to work when you're performing. Can you imagine that, right? Can you imagine me, right, you're going to dance? No, I've got to stop the codes. Let's see, sleep for 0.5 thing. Oh, maybe I want this bass drum again. This is useless, isn't it? House. And then, now we're okay, right? We can dance again, right? Oh, I want to change this. All right. Oh, now we're okay, right? That'd be rubbish. It'd be much better if you could just change the numbers, then press the run button, and it would just do it for you, right? Or I could change this time. Yeah, like this, or I could add like some octaves here. Do some mathematics. Or maybe I want to use a scale, minor pentatonic. Sounds more nice. And you can see actually on the right side when I'm doing the controllers, you can see all the events coming in. So I have an evented system where all the events are totally ordered. It's completely deterministic. Even though it works across the threads, it reorders the computation to do the same thing every time. Because when you make music with code, and I send you some code, I want it to sound the same on your computer as it does on mine, right? And so if we have race conditions, and if those race conditions mean different sounds, that's useless. So I've spent a lot of time making sure things are fully deterministic by weaving the random seeds through everything and by reordering all the state manipulations such that it's the same race condition wins every time. So total ordering of events. So this is also, I'm using multiple processes. I've got C++, I've got Ruby, I've got Erlang, I've got SuperCollider, the synthesizer designed in Clojure. So lots of things working at the same time. So really interesting ideas, evented systems, concurrency, threads, and multiple processes. And so I can carry on, but I am running out of time. And so I'm available. I'm going to put the luminous stand over for the rest of the afternoon, so come and speak to me and ask lots of questions, figure out what's going on. I'd like you to realize a few things. Firstly, this is free. It is available for you to download. Children around the world are using this, and adults and professional musicians, and are performing in large venues with it. And we're going to see, I think, hopefully a lot more people coming out doing amazing things and doing things I couldn't have imagined. And up till now, I've been in a really lucky position to have been funded by the Raspberry Pi Foundation, and they've been fabulous. But unfortunately, they've gone into a different direction, and Sonic Pi is left now without funding. So this is the first time I've actually given a presentation where I'm just giving a plea, really, to say, if you like what I'm doing, and if you know somebody who's had some positive experience by the work I've been created, now is the time to help me. And really, I really mean it, because I've got maybe 4 months of my salary left at the computer laboratory, and after that, I'm out. And so if you like what I'm doing, you want to see this kind of thing continue, then there are 3 main ways you can help. One is that there's this Patreon thing. If I go to patreon.com/Sam Aaron, you can see that there are a few hundred people giving me between $1 and $10 a month. I'm getting $865 a month, which is fabulous, and thank you very much for everyone who's supporting me, but that's not enough to live on. So if we can get that to a higher level, that'd be great. So that's one way to support me, is to donate a cup of coffee a year, right, to me. That'd be really nice. And if everyone in the audience did that, I'll be fine right now. The second way to do that is also if you're a company and you're looking to sponsor conferences or venues, and you normally give some money for your name on the side, perhaps you might be interested in having your name on the front of Sonic Pi. And so that's another thing. So if you're an organization that wants to support what I'm doing, that's another way to talk about it. And then the third and most important way to help me out is just to use it and play with it and share it with other people and have fun with it, because that's really the best way to spread the joy of programming. It's the best way to spread that programming is not just for business, and I hope you all understand that, right? In the same way that language is not just for legal documents. And you all have amazing skills. Every one of you have amazing skills that the world doesn't really understand yet. Why are most of you using that to make rich people richer? Please, some of you change that. Thank you very much.